So you might recall that, or you might have seen before, that the graph of sine of x looks something like a wave. But how do we get this wave in the first place? And you can do this using the unit circle. So let's try to sketch the graph of sine of x. So we're going to try to sketch the graph of sine of x here and see how our graph looks compared to the graph over here. We can do this using the unit circle, and just kind of a quick reminder that when you create an angle on the unit circle, the coordinate where this angle, or this ray, intersects the unit circle, that's going to have the coordinates cosine of theta, comma sine. Now let's say if we create a 90-degree angle. Let's say if we create a 90-degree angle. What will the coordinate where this ray intersect the unit circle be? Well, let's remind ourselves what the unit circle is, right? We said the unit circle is a circle that is centered at the origin and it has a radius of 1. Now this right over here is a radius of a circle, meaning that, this part right over here is 1. So that means that the coordinate of this point has to be 0, 1, right? The x value is 0, right? Because we only have gone 1 up, right? So now we said how sine of theta represents the y value of the angle that we created. So in this case, we created a 90-degree angle, which means that this right over here, this 1 over here, represents sine of 90 degrees. So sine of 90 degrees is equal to 1, right? That's basically what we're saying, right? Sine represents the y value. So on this thing right over here, I'll just put 1 here, put -1 here, and we said that sine of 90 is equal to 1. Let's say that if we create a 180-degree angle now. Let's say that if we created an 180-degree angle. Now, this ray right over here intersects the unit circle at this point. And this is also a radius of the circle, right? This also represents the radius of the circle. Now, right over here, we've gone 1 unit to the left. So that means that our x value is -1, right? We started off at 0. If we went 1 unit to the left, then we're at -1, right? The coordinate -1. And our y value hasn't changed, which means that sine of 180 degrees is 0. Just put one more point. All right. Now, let's say if we created a 270-degree angle. So let's say if we created a 270-degree angle. Well, this time, we've gone 1 unit downwards, right? Because this right over here represents the radius of our circle, which is 1 unit. And because this is a 270-degree angle, well, we've gone 1 unit down, right? We've gone 1 unit down. So the coordinate of the point where this ray intersects the unit circle, so this point right over here, it's going to have the coordinates. Well, did the x value change? No. So the x value is going to stay at 0, and then the y value gone down by 1. So it's going to be 0, -1. Therefore, sine of 270 degrees is going to be equal to -1. It's going to be equal to... Now, what is sine of 0 degrees? What is this going to be equal to? Well, if we create a 0-degree angle, well, if this is a 90-degree angle, this is, let's say, a 45-degree angle, well, theoretically, just the straight line right over here, just this ray right over here would represent a 0-degree angle, right? If we wanted to create an angle that's 0 degrees, well, you would just make the lines, both of the kind of things that create the angle, both of the parts that create the angle, smaller and smaller and smaller, until eventually they're basically just one line, right? So if this is like, let's say, a 1-degree angle, 1-degree angle, well, then theoretically this would be just a 0-degree angle, just a straight. In this case, this is just going to be a straight ray. Now, this ray intersects the unit circle at this point. Since the radius of the circle is 1, this point has the coordinates. Well, we moved 1 unit to the right, which means that the x coordinate is going to be 1. But we didn't move up or down, which means the y value of this point is going to be 0, right? The y coordinate of this point is 0, 1, 0, which means sine of 0 is equal to the y coordinate, so it has to be equal to 0. So that means that when we create a 0-degree angle, our sine value is going to be 0. One important thing to know is that sine of an angle let's say theta, is equal to sine of theta plus 360. This is another important trig identity to know. So, for example, let's say if I have a 30-degree angle. Now, we know that a circle has 360 degrees. All right, a circle has 360 degrees. So if I add 360 to 30, well, all I'm doing is I'm going around the circle one time. So I'm looping around the circle one time, and guess what? I'm back to where I started. So I'm going to have the same ray, I'm going to have the same y coordinate, and I'm actually also going to have the same x coordinate. Just to summarize everything, we know that sine of an angle represents the y value of this coordinate, right? And if you add 360 degrees to our unit circle, you're basically rotating around the circle one time, and you're coming back to the same point, right? So that's kind of why sine of an angle is equal to sine of that angle plus 360 degrees, right? Because the y value, if you go one time around the unit circle, that's going to remain unchanged. And guess what? So is the x value, which we know is cosine of theta, right? So that's why sine of theta and cosine of theta is equal to whatever their angles are plus 360 degrees. And you're just kind of like repeating loops around the unit circle, but the value of that point stays the same. So knowing this, well, we know that sine of 0 degrees, we said this is equal to 0. And we said how sine of an angle is equal to that sine of that angle plus 360 degrees, which means that sine of 0, which we said that was our original angle, right? Sine of 0 plus 360 degrees, well, we know they have to be equal to each other, which means that sine of 360 degrees has to be equal to 0. So sine, that also kind of makes sense if you look at the unit circle, right? If this is a 0-degree angle right over here, this is a 0-degree angle, well, if we go 360 around the unit circle, well, it's also kind of the same. It's going to have the same value as the 0-degree angle. So sine of 0 is going to be 0, which means sine of 360 is going to be 0 as well. Notice how, we can kind of connect these points. If we were to kind of find out all of the other values in our unit circle, if we were to find kind of every value on our unit circle, so this angle, this angle, this angle, you would get kind of this connected line that looks kind of like a wave. Okay, we have half of the graph ready. Now, what about this negative part right over here? What even is a negative angle in the first place? So I'm going to draw my unit circle. Now, we know that a positive angle, so when we create an angle on a unit circle, this right over here is a positive angle, right? So let's say this is a 30-degree angle, right? However, another way you can think about this is you can kind of measure it backwards. So whenever you measure an angle from, let's say, a counterclockwise direction, so you measure this angle from a counterclockwise direction, you're going to get a positive angle. However, if you measure this angle right over here, you can measure this angle from the negative direction, right? You can measure it from this other direction, and this is going to give you a negative angle. For example, let's say that if I create a 90-degree angle. Let's say if I create a 90-degree angle. So it's this angle right over here, right? You can clearly see that it's 90. This angle right over here is 90 degrees. Well, I can create a negative part of this. I can create a negative angle that's like this, right? And this represents this angle, which is, well, we have 90, 90, and 90. So this angle right over here is going to be negative 270. All right, it's just going to be all of those angles added up together, and you just put a minus sign at the front. So it's negative 270 degrees. So when you create a 90-degree angle, it's going to be the same thing as a negative 270-degree angle. And guess what? If you plug these two things into the formula, it works, right? If you have sine of negative 270, it's going to be equal to sine of negative 270 plus 90 plus 360 degrees. All right, plus 360. Negative 270 plus 360 gives me 90. So sine of 90 is equal to sine of negative 270. So let's do another example. So let's say if I created a 135-degree angle. Well, what is the kind of negative part of 135? What is this angle expressed in kind of a negative angle? Well, all you have to do is, in this case, what you can do is you just go counterclockwise and measure the angle from there. So if you go counterclockwise, well, this is 90 degrees, this is 90 degrees, this is going to be 45 degrees. So 90 plus 90 plus 45, that is going to give me 225. And you just slap a negative sign in the front. And that is kind of the negative counterpart of this positive angle. So whenever you're trying to find a negative angle, you just measure it from the other way, right? A positive angle, we saw how a positive angle, we can get it from just going counterclockwise. However, if you were to measure the angle from a clockwise direction, well, you would get the negative version of the angle. And kind of you add up the angles the same way as if you were doing kind of a regular angle. So keeping this in mind, well, we know that negative 90 degrees, so let's say if we want to find out sine of negative 90, right? So we have our unit circle. Now, if we want a negative 90 degrees, well, all we have to do, instead of going 90 degrees counterclockwise, right, this is a normal 90-degree angle, right? However, if we want to find out sine of negative 90, instead of going 90 degrees counterclockwise, we would go 90 degrees clockwise. 90 degrees clockwise. And this would give me my negative 90-degree angle. Now, notice how if I plug negative 90 into my formula, right, I get sine of negative 90 is equal to sine of negative 90 plus 360, which is 270. We know that sine of 270 is negative 1, so we can just plot that here. What about negative 180 degrees? Well, if I plug it into this formula, sine of negative 180 is equal to sine of negative 180 plus 360. That's the same thing as sine of 180. Sine of 180, we saw that it's equal to 0, right? So this is going to have the same thing. And this is actually just going to repeat again. It's just going to go up, then down, then up, then down, and just this pattern is going to repeat over and over again. Now you might be wondering, well, why kind of when I graph in Desmos, well, why does it show me, well, actual numbers? Why doesn't it show me an angle? Well, these are angles. They're just expressed in another unit, radians, which I have covered in this video. So for 0 degrees, well, I could just put 0 here. For 90 degrees is the same thing as pi over 2. 180 degrees is the same thing as pi. 270 degrees is the same thing as 3 pi over 2. 360 degrees is the same thing as 2 pi, and so on. And you do this for the negative side. You can do this for the negative side as well. Final thing about y is equal to sine of x is that one thing you notice is that this graph never crosses y is equal to 1 and y is equal to negative 1, right? All of the values in y is equal to sine of x are kind of contained in between these two lines, right? So any x value that you put in there, if you put in the x value to y is equal to sine of x, the y values are going to be in between negative 1 and 1. So that's something important to know. That, well, if we want to look at all the possible x values for this function, well, it turns out that this function actually goes on to infinity. All x values work for this function. All right, so that's another important thing to know. And that comes back to kind of the trig identity I talked about before, where sine of x is equal to sine of x plus 360, right? Which means that, let's say if I have sine of, that means that sine of 360 is going to be equal to sine of 720 degrees, which is going to be equal to sine of 1080 degrees. And notice how I can just keep adding on 360 degrees, right, to my angle, right? And all of those are going to be equal to each other, and it's just going to keep going on into infinity if I kind of added more and more 360s to my angle, right? This graph is just going to keep going on and on forever. So that's another important thing about sine. its domain is actually all real numbers.